Hello students, in today's class we are going to discuss equivalence relation, one special type of question. What is the question? C set of all complex numbers. And C naught set of all non-zero complex numbers. Then let us consider a relation R. R is a relation such that R with the domain C naught it is C naught cross C naught. Actually R is a relation defined on the set of non-zero complex number. R is a relation on a set of non-zero complex number such that Z1 is related to Z2. So there is a relation between Z1 and Z2. There are two non-zero complex number, and if Z1 minus Z2 by Z1 plus Z2 is purely real number. So whenever the expression Z1 minus Z2 by Z1 plus Z2 is a real number, we can conclude the two complex numbers Z1 Z2 are in relation. So whenever the two complex numbers are in relation, so this must be true. Z1 minus Z2 divided by Z1 plus Z2 is a pure real numbers. Okay. Then what is equivalent relation? And we have to test three. The first one, reflexive. The second one, symmetric. And the third one, transitive. If any relation is true for reflexive, symmetric and transitive, then straight away the relation is said to be an equivalence relation. So to confirm the equivalent relationship of the relation R on a non-zero complex number C naught, a set of non-zero complex numbers C naught, and we have to discuss reflexive, symmetric and transitive. Okay. So let us start with the discussion of reflexive. Listen, Z1 is related to Z1, then Z1 in the place of Z2, no, we should have to take Z1. Z1 is related to Z1 only when Z1 minus Z1 by Z1 plus Z2 is real. Listen, Z1 minus Z1 0, 0 by any complex number 0, 0 is real number or not? So real number. So whenever Z1 minus Z2 by Z1 plus Z2 real number, Z1 is related to Z1. So pre-image and image no coincide. So whenever pre-image and image coincide, the relation is said to be reflexive. Because of Z1 minus Z equal to 0, this 0 is a real number. Z1 related to Z1 since Z1 minus Z1 by Z1 plus Z2 equal to 0. So this is reflexive. Then second one, remember Z1 is a arbitrary complex number, arbitrary non-zero complex number. We have to take here Z1 is not equal to 0. Z1 is not equal to 0. This is not of the form. Remember, Z1 is not of the form 0 plus I is 0. Either A is non-zero or B is non-zero, or both A and B are non-zero. Okay, so if we take any complex number, arbitrary complex number, Z1 minus Z1 by Z1 plus Z equal to 0 means this is true for all non-zero complex numbers. So what is the conclusion? The relation R is reflexive on a set of all non-zero complex number C0. For symmetric, and we have to take two members. So Z1 minus Z2, Z1 plus Z2 is real number, means Z1 is related to Z2. Let us consider, let Z1 is related to Z2. So because Z1 related to Z2, then we can take Z1 minus Z2 by Z1 plus Z2, a real number. Just we interchange the numerator, instead of Z1 minus Z2, minus of Z2 minus Z1 by Z1 plus Z2 is also a real number. If it is positive real number, this is going to be negative real number, or the given one negative real number, this will be positive real number. So just differ by sign alone. So both are real number. So Z2 minus Z1, or we can take Z2 minus Z2 on the other side. So also real number, negative. Because of Z2 minus Z1 by Z1 plus Z2 real number, we can conclude Z2 is related to Z1. That means whenever Z1 comma Z2 belongs to R, Z2 comma Z1 also belongs to R. The same thing, or alternately we can write Z1 comma Z2 belongs to R, and Z2 comma Z1 also belongs to R. So if Z1 comma Z2 belongs to R, means Z1 minus Z2 divided by Z1 plus Z2 should be real number for that also. So according to our discussion, it's symmetric and reflexive. Now we have to discuss the third one, a transitive case of the relation R on the set of non-zero complex number C0. Let's go through it. Third one, to discuss equivalence, that is transitive relation. We have two members, Z1 comma Z2 belongs to R, and Z2 comma Z3 belongs to R. So Z1 comma Z2 belongs to R, then Z1 minus Z2 by Z1 plus Z2 real number. So let it be alpha, a real number. And Z2 comma Z3 belongs to R, mean Z2 minus Z3 divided by Z2 plus Z3 another real number beta, a real number. Okay, taking reciprocal z1 plus z2 by z1 minus z equal to 1 by alpha and z2 plus z3 by z2 minus z3 1 by beta, real number, applying componendo and dividendo rule. What is componendo dividendo? A by B equal to C by D. Applying componendo dividendo between these two ratio, A plus B by A minus B and C plus D by C minus D. So this is output applying componendo dividendo. If you apply componendo dividendo between these two ratio, this is the result. A plus B by A minus B. The other side, sum and difference, sum difference. So applying componendo dividendo, this is reduced to z1 by z2 equal to 1 plus alpha by 1 minus alpha, and then z2 by z3 equal to 1 plus beta by 1 minus beta, multiplying both sides, and z2 cancel, z1 by z2 equal to 1 plus alpha by 1 minus alpha and 1 plus beta by 1 minus beta. Then z1 plus z2 or z1 by z3 equal to the whole thing real number, let it be gamma, a real number. Then apply componendo dividendo, z1 plus z3, z1 minus z3, 1 plus gamma by 1 minus gamma, and taking reciprocal z1 minus z3, z1 plus z3 is 1 minus gamma by 1 plus gamma, also a real number. See, for the two members z1 z2 belongs to R and z2 z3 belongs to R, we have concluded z1 minus z3 by z1 plus z3 also real number. Mean, what is the conclusion? z1 pre-image, the corresponding image z3 also part of the relation. So this shows that the relation is transitive. Remember, now we have to conclude. The given relation is reflexive, we proved, symmetric, we proved. Now we have proved transitive also. That's why the given relation is equivalent relations. This is one of the important questions, and watch 1 or 2 times until you get complete understanding. Thank you, student. We will meet the next HOTS types of the question. Thank you.